So hi everyone, in the previous videos, we have discussed about demand paging as well as its performance, okay? So let us recall this specific instance wherein the CPU tries to access this page that is not loaded in the main memory. So as we have discussed, a page fault happens, right? So if a page fault happens, we transfer the control to the OS and the OS requests the desired page and then swap in that desired na page into the main memory, and then update the page table. So what we are actually looking here is we look for available na frames wherein we can load the page that is being requested by the CPU. So in this case, the page 2 of process 2. Okay, now, what if there is no free frame? So what if there are no available na frames into the main memory? So we do the page replacement na mechanism wherein we find some page in the memory but not really use it, so we swap it out. So basically, what we can do is we can look for certain pages loaded in the main memory that is not that used by the CPU anymore or less frequently used by the CPU anymore. So we can swap that out and then replace it with a desired na page that we need. Okay, so there will be several na algorithms for page replacement and that we will discuss in the next few na videos. Okay, and of course, we want that our algorithm will result in a minimum number of page faults. Okay, so before we discuss this page replacement na algorithms, let us discuss first what happens in the page replacement. Okay. So as I mentioned earlier, let's say the CPU wanted to access some page. Let's say it tries to access the page 2 of process 2. But we can see that it is invalid, so a page fault happens. And if you remember, what we did was we requested from the secondary memory and then load it in the main memory. Okay, swap in, swap out. However, we can see that currently the main memory is loaded, or there are no available na holes in the main memory. So there is no free na memory. So what happens now? What are we going to do? So the technique of the page replacement is that we are going to look for some pages loaded in the main memory that is not really used anymore by the CPU. So assuming that we select this page E, okay, in frame 6. So we call it as the victim frame. So assuming that we select this frame 6, and let's just say that E is no longer used anymore. Okay, so it's just an assumption. Now, what we are going to do is this page E in frame 6 will be swapped out of the main memory. Okay, so swap out. That means that we now have an available na hole in the main memory. And what we do is we are going to update the page table. And the E was page 0, right? So what we do is the page 0, we change its bit into invalid, and the frame will be blank since it's no longer loaded in the main memory. And after that, we are going to swap in the desired na page. So our desired page is page 2, which contains the G. So we swap that into frame 6. And what we do now is we are going to update the page table. So as you can see, the page 2 is now on frame 6, and we also change it bit into valid. Okay, and next is we are going to restart the instruction. Okay, now the question is, how do we actually select the victim? And well, there are several page replacement algorithms that we can make use of. These are the first in, first out, the optimal na algorithm, or the LRU, or the least recently used. And we are going to have a separate na video for each na algorithm. So that's all.